Landings, Part 1. The most challenging and unnatural maneuver in aviation. Hi, Doug Daniel again. In this video, you will learn the landing profile from approach glide to rollout, the three phases of any landing, why good pilots do not land their airplanes, the importance of airspeed, height above the runway, and timing, what to focus on to keep landing simple. We study this because all flights end with a landing. Landing is the most difficult piloting maneuver any of us will likely encounter. This is the most dangerous regime of flight. And we get our most ego gratification from showing off landing skills. To avoid introducing too much material too fast, we assume a low altitude airport with smooth hard surface runways. Landings require using the elevator flaps and throttle almost independently of aileron and rudder, so the aileron and rudder must be used in close coordination in a way that will surprise you. We start by studying those aspects of landings that depend mainly on the elevator flaps and throttle. Next, we study aileron and rudder coordination. After knowing how to land in these idyllic circumstances, we move on to face reality. No pilot ever executes a landing perfectly. All landings are a series of, hopefully, minor corrections. So we need to understand how to recover from those little things that go wrong in every landing. Having mastered hard surface runways, we are ready for runways that are muddy, soft, rough, high, and short. As an extra bonus, I'm going to show you some little known but very effective ways of practicing landings, techniques that will substantially enhance your skills and use your time very effectively. So in this video, we focus on the landing profile with an emphasis on elevator flaps and throttle. I think I've already said that. Introduce the three phases of a landing, discuss rollout techniques. First, we need to review the fundamentals. Airspeed is controlled by all three of these: pitch, attitude, power, and drag. Lift is controlled by all of these: angle of attack, aircraft configuration, which usually means flaps, and airspeed. Of these, airspeed has the greatest influence. Increase your airspeed by 10% and increase your lift by 21%. Keeping landing simple. Many things happen during a landing, too many things to concentrate on. We need to understand all that happens, but we need to identify the parameters that need our attention. So we divide a landing into three phases. Analyze each phase carefully. Identify the critical parameters in each phase. So the three phases of a landing are the approach glide, the transition, also known as the flare to land or the round off, and slow flight. Here the three phases are again in three dimensions. You'll notice that there's the approach, the transition, and the slow flight just above the runway. As much as circumstances allow, be consistent. A poor approach glide will make the transition more difficult. A poor transition will make slow flight over the runway more difficult. All of these phases of a landing are equally important. Starting with the approach glide, always project your glide toward the same spot. Most pilots use the runway numbers. Always glide at the same indicated airspeed. The FAA recommends 1.3 times the stall speed of the airplane in a landing configuration. Always glide in the same configuration. I recommend full flaps and an idle or near idle power setting. Note that the steeper the glide, the more precisely you can control your projected glide point. Glide path is also controlled by all of these: pitch, attitude, power, and drag. Airspeed can be held constant while you change your glide path by changing pitch and power or changing pitch and drag. You need to control your projected glide point. As you approach the runway, there will always be some point that does not move in your field of view. Everything around it seems to move away from it. This point is the projected glide point, the PGP. Here I have a computer animation of a projected glide. We put the glide point right between 2,7, and if you notice, it stays steady on the screen. Everything else moves away from it. That's what you look for. If you need to move the PGP farther, pitch up, add power or reduce drag. 99% of the time you'll add power. If you need to move the PGP nearer, pitch down or reduce power or increase drag. 75% of the time you'll reduce power. The transition from glide to slow flight. At about 1 wingspan above the runway, start a slow pitch up. Your objective is to gradually slow your rate of descent until you are in leveled slow flight at no longer descending when you reach about 1 foot or less above the runway. This maneuver is all about timing. Raise your nose too abruptly when you start the transition and you will be going too fast. You will develop enough lift to start climbing again. Raise your nose too slowly and you will strike the ground, possibly nose wheel first. The nose wheel is certainly the most fragile part of your landing gear. Start the transition too early and you will enter slow flight too high, stall, and risk striking the runway. Start the transition too late and you will not be able to slow your descent quickly enough to avoid a ground strike. Don't worry, there are ways to recover from all of these situations. If your approach glide was too fast, your wings will generate too much lift when you raise your nose and you will start to climb. If your approach glide was too slow, you will not be able to generate enough lift before your airspeed dissipates and you will strike the ground. These two problems, the ones above that we were just talking about, are very easily prevented by flying a precise and consistent approach glide airspeed. By the time the pilot has flown an hour or two, he or she can control airspeed within a knot or so. So if you find that you are not controlling airspeed well, make certain that you are keeping the airplane trimmed and that you do not have a death grip on the controls. Slow flight over the runway. The desired end state of the transition is to be in slow flight at a foot or less above the runway. But the approach airspeed of 30% above stall speed has a safety margin built in. This means that you will be well above stall speed when you enter slow flight. Once you are in a high drag, low power configuration, you will be losing airspeed. But as the airspeed declines, so does the wings lift. To maintain that constant height above the runway, you must compensate for the loss of lift by increasing your pitch attitude as the airplane slows. Here's where the airplane lands. You can let the airplane land by holding constant attitude once you have reached what you consider to be the landing attitude. This is called an attitude landing. I don't advocate it for students because the landing attitude is not well defined. If that attitude is not enough nose up, the pilot will start to land too fast routinely. Nevertheless, attitude landings tend to be smoother and gentler. They are the norm for heavier airplanes. You can keep the airplane flying until it stalls. Called a full stall landing, it has the advantage of putting the airplane on at the lowest possible speed, and the disadvantage of going kerthump. I recommend full stall landings at first. You will learn attitude landings when you do soft or rough field landings. Why is landing slow important? The slower you land, the less force a gust of wind can exert on the airplane. The less braking is needed to slow the airplane, the shorter the required runway length, and the easier it is to control the airplane on the runway. So why let the airplane land? If you decided, okay, time to land, and put the airplane on by pushing forward with the controls, you would hit hard, be going faster than you needed to, risk damaging the nose wheel, or in a tail dragger most likely bounce. If you let the airplane land, especially from a landing attitude, the airplane loses airspeed slowly, loses lift slowly, and lands gently. Since general aviation aircraft do not stall instantly, a full stall landing also puts the airplane on the ground almost as smoothly as an attitude landing. So here are the cues for landing, what you should be looking for, what you need to keep landing simple. During the approach glide, move the projected glide point to where you want it by simultaneously adjusting pitch and power while maintaining the desired approach airspeed. Or, another way of looking at that is that you are in this point using your elevator to control airspeed. Constant and precise airspeed at the end of the approach glide is critical. During the transition to slow flight, you no longer use your elevator to control airspeed. In fact, you no longer even monitor the airspeed indicator. Use your elevator and indirectly pitch attitude to control your rate of descent. Just like when you stop a car, you push on the brake so that you stop just as you get to the stop sign. Use your elevator to slow your descent until you are about a foot, or for you, Olivier, 30 centimeters, above the runway. During slow flight, once again your elevator takes on a new role. Use it to hold a steady height above the runway. You slowly increase pitch attitude, but your mental focus is on height. Now let's talk about that unnatural rollout. When you land and you see the other end of the runway approaching quickly, the natural tendency, it was for me once, is to try to push the airplane onto the ground to make the brakes work more effectively. I was flying a Cessna 172 from Livermore down, which is in Northern California, down to a small airport, Southern California. The airport that I usually flew at was 4,000 feet long. The airport that I was landing at was 1,500 feet long. So I landed right where I should have, at the airspeed I should have landed at. Then I saw the end of the runway coming up very rapidly. So I slammed the controls forward as hard as I could, stepped on the brakes, made an incredible amount of noise, and it seemed like I was never going to stop. I stopped the airplane less than 100 feet from the far end of the runway. That doesn't work out real well. So, guess what? On rollout, when you push forward on the controls, the elevator goes down. When the elevator goes down, the tail has additional positive lift. When the tail has additional lift, it pulls up on the main gear. When the main gear are lifted, the brakes don't do much. But when the pilot pulls back on the controls, the tail pushes down, putting more weight on the brakes, making them more effective, which is what you wanted to do. So you have learned the landing profile from approach glide to rollout, the three phases of any landing, why good pilots do not land their airplanes, the importance of airspeed, height above the runway, and timing, and what to focus on to keep landing simple.